Hi students, welcome. In this video, we are going to discuss about some basic concepts of chemistry. It's an introductory topic for our preparation of competitive exams. So when it comes to the initial discussion of this topic, what we start with is the definition of chemistry. So let me take you to the definition of chemistry. So what we are doing, we are defining chemistry. So yes, I suggest you to think as well. So tell me, what is the meaning of chemistry? So it's a branch of science, right? When I say chemistry, most of us actually must be thinking of some chemicals which we use in day-to-day life, or some chemical reaction which occurs in our nature, or some other process that involves surely atoms and molecules. So when we say chemistry, it is branch of science that involves involves study of study of matter, its transformation. That means how matter changes from one form to another, one substance to another, properties and principles involved in this, aspects of behavior of different substances. Okay, so basically when I say chemistry, it's all about study of atoms, molecules, basically matter. So it can also be said as study of atoms and molecules, basically study of matter. So when I say matter, how do we define matter? Let's define matter. We know this universe is made up of matter and energy. We actually will be discussing the relationship between matter and energy, how matter interacts with energy, what transformations energy can bring about in matter. So these things also we'll be talking about. But right now in this topic, we will be discussing about the classification of matter. So what is matter? Matter is anything that occupies space and has mass. So that's how we define the matter. Now, how we classify this matter? Matter is classified in two important ways. One is based on physical state, that is called physical classification, right? The other one is called chemical classification. Chemical classification. So first we will look at physical classification. So what is the basis of this classification? It is based on the physical state of the substance or phase of the substance. So based on physical state of matter or substance. So there are mainly three types here. The first type is solid state or solids. The second type is liquids. The third type is gases. There are other two as well: Bose-Einstein condensate, plasma. This generally we don't discuss in our competitive exam syllabus. It's always for higher study. So now we will take up the discussion of important properties of these three physical states. So first we will look at solids. So what is a solid? Solid is basically substance which has particles tightly packed, and particles have very high interatomic or interparticular or intermolecular forces, and the particles cannot move from one point to another. They can only vibrate about their mean positions. So when I say solids, in this solids, the particles are closely packed, negligible, intermolecular space, and when I look at intermolecular force, it will be maximum. So high intermolecular forces. And another interesting aspect about solids is that they are very rigid. They are rigid and have fixed shape and volume. So that means the solids have definite volume and definite shape. Generally, they exist at low temperature and pressure. Yeah, there are solids which exist at ordinary condition as well, but most of the substance which cannot exist as solid at ordinary condition will also be solids at very low temperature and pressure. Okay, so next we will look at liquids. When I say liquids, in this particles are quite far from each other. They are not very closely packed. So particles are moderately spaced. That means particles exist at certain distance from each other, and the intermolecular force or interparticular force is also very moderate. It's not like in case of solids. So interparticular, instead we can say intermolecular intermolecular forces are moderate. And apart from that, liquids have moderate intermolecular space. That means there is some space available. There is some space available even in solids actually, but that is very negligible compared to the space available between the particles in case of liquids. And apart from that, they have definite volume but no shape. Because of that, what happens? Liquids occupy, or they take the shape of container and take the shape of container. So that's a very important aspect of liquid. And very important aspect is what? These liquids exist at moderate temperature and pressure. At very low temperature, liquids can't exist because they tend to become solidified. Next aspect what we would like to talk about is gas. So gases have particles far away from each other. From each other. So they have particles far away from each other. That means they have poor intermolecular forces. And obviously, because intermolecular forces are poor, the particles are very far. That means they have large intermolecular spaces. They have poor intermolecular forces, large space between particles. Particles. And another interesting aspect is no fixed shape or volume. Basically, gases cannot be stored in open container. They just escape to atmosphere. So we need closed container to store gases. So these are most important aspects about the physical states what we have: solids, liquid, and gases. So when I classify matter in this way, we look at the physical state of these substances. So next type of classification what we are going to discuss is chemical classification. Chemical classification. So what is this chemical classification? This is based on the chemical composition of the matter. This is based on composition of matter. So based on this composition, we have mainly two types: pure substances and we have mixtures. Okay, we have pure substances and mixture. So what is a pure substance? There are few important aspects or features of pure substance. Pure substances have fixed composition, right? They have fixed composition. Like we have water, we have gold. So when you take gold, the composition of gold is simply gold atoms, right? Similarly, when you take water, composition is simply water molecules, considering water to be pure water. Now, what other aspects we can think of apart from that? What other aspects we can think of is they cannot be separated by physical methods. They cannot be separated. That means, suppose we have water. Water is made up of H2O. Hydrogen and oxygen cannot be separated by physical methods. Cannot be separated by physical methods. So that's a very important trait of pure substance. What about mixture? Mixture does not have fixed composition. Does not have fixed composition. Let's take a lemonade, or let's take any mixture for that matter. Say when we mix salt and water, when we mix sugar and water. Now this composition of sugar and water is not fixed. What I prepare sugar solution may be different from what you prepare. So the composition of the mixture is never fixed. But when we consider pure substance, say water, carbon dioxide, ammonia, SO2, so all these compounds have certain specific ratio in which each element is combined. So that is the meaning. They have fixed composition and they cannot be separated by any physical method. However, if you look at mixtures, mixtures can be separated. The components of mixture can be separated by physical means. by evaporation. Certain mixtures can be separated by evaporation or by sublimation or by decantation. So there are different methods which we generally learn in lower classes, which can be used to segregate the components of mixture. So the next aspect which I would like to note here is they can be they can be separated by physical methods. Physical methods like filtration, evaporation, decantation, etc. Okay. Now, this pure substance as well as mixture can be further subdivided into other categories. So here I have example of some pure substances. So yeah, let's discuss the subcategories in pure substance. You have elements and you have compounds. So elements, when you say, it is made up of only one type of atoms. So made of only one type of atoms. What about compounds? Compounds contain more than one atom. So they are made up of two or more atoms. Two or more atoms. So that's the difference. Example, you can take H2O, carbon dioxide, ammonia, etc. There are many. Similarly, for elements, we have gold, copper, carbon. These are all elements. So I have got some examples here. If you see, so this is copper, right? This is copper and it is metal, right? So that's a element. Then we have other metal blocks here, like this one is aluminum, this one is gold, right? And this one is silver. Then we have lead. So like this, these are all different elements. These are all metals actually. So that's another way to classify the elements. So there are mainly when you classify elements, you have got metals, and we have got non-metals. We do have metalloids actually. So that is another category which we should be uh, not missing. That is metalloids. Okay. So we have got three different types of elements. So metals, when we say again, metals can easily lose electron, and metals have their own unique properties, but they all are made up of one type of atoms. So copper is made up of only copper atoms, gold is made up of only gold atoms. So here in some examples of non-metals we have, that is bromine. So we'll write just bromine. Then we have carbon. Then we have sulfur. Then we have phosphorus, right? So these are different elements. Then coming back to compounds, we have already written some examples here. More examples if you would like to. Surely you can think of urea, sugar, right? Sugar, salt. So by default, when we say salt, it is NaCl, right? So these are different types of compounds. Now, what is the difference between a compound and element? I believe is very clear. Compound is made up of more than one atom, two or more atoms, and element is made up of only one type of atom. Now, this compound also can be subdivided into compounds can also be subdivided into ionic and covalent. Ionic compounds means what? They are made up of ions. So they contain ions like NaCl, KNO3, etc. Okay. So they have intermolecular force as ionic bond. Then we have covalent compounds like methane, sugar. These are all examples of covalent compounds wherein we have covalent bond, right? So more about bonding and types of compounds will come in our further study. For time being, we will be just looking at the composition of the matter. So second category which we had here is mixture. So let us take types of mixture here. So we have got different types of mixture. Okay. So when we say mixture, it will surely have more than one type of elements or the substance. It's not pure substance because the composition is not fixed. It can keep varying. Now in mixture, when we say there are two types of mixtures. First type is homogeneous mixture. Homogeneous mixture. The second type is heterogeneous mixture. Heterogeneous mixture. So what is a heterogeneous mixture? Heterogeneous mixture has what is a heterogeneous mixture? Heterogeneous mixture has more than one type of substance, obviously, and they are not uniformly distributed. So components are not distributed not distributed uniformly. So that's a very important aspect, right? That's a very important aspect. Uniform distribution of components is not observed in heterogeneous mixture. Homogeneous mixture means what? The components are distributed uniformly. So that's a very important aspect for these homogeneous and heterogeneous mixtures. And another aspect is they have uniform density throughout. Throughout. What about heterogeneous mixture? Density is not uniform. That means density changes in different parts of the mixture. So that is the meaning of non-uniform density. Okay, example, if you take mixture of oil and water is a very good example. Mixture of graphite and diamond, sand and sugar. These are all different mixtures which are heterogeneous in nature. Then we have homogeneous mixture. All solutions, true solutions, what we call. like solution of NaCl in water, solution of sugar and water, solution of different ionic compounds which are soluble in water will always be homogeneous in nature. So NaCl plus water, then we have NaOH and water. These are all very good examples of homogeneous mixture, HCl and water. So they all form a very good example of homogeneous mixture. Now we have classified the matter in two different ways, that is physical classification and chemical classification, which is based on the chemical composition.